Hello students, welcome to Unit 9 Notes Section 10.1. At this time you can pause the video to write down the warm-up. Don't forget you do not have to print out the notes packet, but you should be following along on a separate sheet of paper just to stay current with it. Okay. There is a little note there, count the number, the length, not the number of dots, so that you don't mess up counting your length. All right, well, we'll start the lesson. What you'll notice in this lesson is I have a lot written down already. Actually, I have everything written down. My sound was not recording the last video, so I have to redo this one. But I will just reiterate what I had written down instead of writing it all back down again, because it's pretty simple. It's area of rectangles and parallelograms. So we have areas of parallelograms and triangles and rectangles. I put them all together here. The most important part is the word base, the word height, and altitude. So we'll talk about all three of those right now today. A rectangle, you know the area is base times height, but so is the area of a parallelogram. Parallelogram is shifted over. So you have your base here. It can be any one of these legs. In this case, it's calling this the base. And the height is what we call an altitude. So the height can be on the inside or on the outside, theoretically, of where it would intersect with the base of a triangle, base of a parallelogram. So an altitude goes from your highest point all the way down to the base forming a right angle. It has to be perpendicular for it to be a height. Same thing if I were to, like I said, drag this all the way over, the theoretical intersection would be out here, but that can still be a height. It does not have to be on the inside of a parallelogram or a triangle. Okay, so here you notice a diagram again with a base which is in red or pink, and then a height which is an altitude. Here you see this base with an altitude on the outside. Remember, you could have 4 unique bases for unique altitudes. What you'll notice is that they're actually not unique. 2 of them will be the same as the other ones, in a parallelogram at least. In a triangle, there could be 3 unique altitudes and 3 unique sides called bases if it's scalene. Okay, so that's that. The area, again, of a triangle is your 1/2 base times height. Think about if you had a rectangle. Let's say we had a rectangle and I were to shrink it, let me fit that right there, boom. You have half of it, right? You have one triangle, but you don't have the other. You have one triangle, but you don't have the other. So you literally have half of what a rectangle's area would be. So half base times height. Okay, so we have example 1, and in this example, we had to find the area of our parallelogram. So we were given, ironically, a base, and we were given 2 bases, but one of them is the easiest one to use, 5 with a height of 4. So I did area is base times height, so area is 5 times 4. Inches times inches is inches squared. So the area of this parallelogram is 20 inches squared. Now, could I have used 4.5? No, not really. Because not to find the area of the parallelogram, because we don't have a height coming down this way or this way. So it's kind of there to trick you. So what I also did was I did the area of, I did the perimeter. So there's 2 4.5s and there's 2 5s. This was not a question it asked me, but I figured why not? So 4.5 plus 5 plus 4.5 plus 5. So that's 4.5, that's 9, plus 10 more is 19. So I wrote it a little bit differently, but yep. 4.5 plus 5 is 9.5 times 2 is 19. Okay, our second problem, again, a few numbers are there to trick you. The 4.6 is there to trick you. The base here is simply 2 times 3.5. So base is 2, 3.5 is the height. So I put that into my equation, and I get 2.5 times 3.5 is 7. Centimeters times centimeters is centimeters squared. Again, I just did the perimeter. I did it a different way. I just did 2 and 2 and 4.6 and 4.6 just because I had the time to do it. So the perimeter there is 13.2. All right, not involving the 3.5. Okay. The next question said find the area of a parallelogram with base 12 meters and height 9 meters. They don't give you a diagram, but you don't need one. You just write your equation again, area is base times height, and then you do 12 meters times 9 meters, and you get 108 meters squared. All right, the next problem. The area, feel free to, I'm going through this much more quickly because I already have it written down. Pause it if you need to pause, and then hit play when you're ready to resume, okay? All right, the area of a parallelogram is 24 inches squared, and the height is 6 inches. Find the corresponding base. So in this problem, they gave you not base and height, but they gave you area and height. So we need to find a base. So what I did was I substituted 24 inches squared in for my area. I substituted 6 inches in for my height, and I left base as a variable. So very quickly, I divided both sides by 6 inches to get this to go away. And what also goes away is inches squared divided by inches. Squared inches divided by inches are just inches. That's all that's left over. So 24 divided by 6 is 4. So the base of this is 4 inches. You can double check by multiplying 4 times 6, which is 24 inches squared. So that's a reverse, you're working backwards, and you're going to have a lot of working backwards problems on the test, possibly even on the IXL work. Okay. All right. This next question is find the missing dimension. We have a parallelogram, and we want to find what CF is to the nearest tenth. So when I take a look at this, I have a base here, AB, and I have a height, which is DE. I also have a base here, AD, and a height here, FC. The height here is an altitude, the height here is an altitude. So what I did was I just multiplied my base and my height to find what my area was. So area is base times height. So here's your base, 10 inches, times your height, 12 inches, and that ends up being a total of 120 inches squared. But what I want to do is I want to change my point of view. I want this now to be the base, and I want to know what the height is. So let me put in x as my height for variable, or just leave it h, and then do 13 for my base and work backwards. So 120 inches squared equals base times height, which base is 13. Divide both sides by 13 inches, and you get about 9.2 inches. So what I did was I worked forward to get the area, then I used the area to work backwards to find a missing height, which is about 9.2. If you do the math, 9.2 inches times 13 inches is almost 120. Because of rounding, it changed a little bit. And I think it was like 119.6 or something like that. All right, the next one. A parallelogram has sides 15 and 18. The height corresponding, so these are both bases, right? These are both bases because it says the word sides. So we know that they're bases and they're not heights. So that would be one, that would be the other. The height of the height corresponding to 15 centimeters is 9 centimeters. Find the height corresponding to 18 centimeter base. Well, the first thing I did was I wrote areas base times height and areas base times height. The areas are the same because it is the same parallelogram. I put in 15 here first, and then I put in 18 here as well. I wrote both of these out at the same time. But what's corresponding to 15 is a height, which is 9. They didn't give me my height here. I need to solve for that height. So I did 15 times 9, which is 135. Centimeters times centimeters is centimeters squared. And now I'm going to substitute 135 centimeters squared in for the area. And now I can work backwards to solve for my height. So 135 centimeters squared equals 18 centimeters squared times height. Divide both sides by 18 centimeters squared, 18 centimeters, and you get 7.5 centimeters. Here's another way of looking at it. Base times height equals base times height. Because the areas are the same, so are the bases and heights when multiplied together. And then I filled in my 1, 2, 3 pieces of information to which I would then have to solve. And I would still get the same answer for that particular height. All right. There's only a couple more. Finding the area of a triangle. Here we are using the area as 1/2 base times height. 13 is there to trick you. 5 and 12 are the base and the height because of this right angle here. 5 is an altitude and 12 is a height. Is a base. Or we could say that 12 is an altitude and 5 is a base. It doesn't matter. So 1/2 times 12 times 5. So 1/2 of 60 centimeters squared. 12 times 5 is 60. So half of 60 is 30 centimeters squared. All right, the next one. 1/2 base times height. Again, it's a triangle. The textbook puts 4 in there to confuse you. Don't get confused. You don't need to use that at all. We don't need to find the area of the total thing and then take away the area of what's not shaded to find the area of what's shaded, because we are given an altitude and we're given a base. And that's all we're going to need. So area is 1/2 base times height. So area is 1/2 of 10 times 6.4. In this case, 10 has to be a base. We don't have an option. And then 6.4 times 10 is 64. Feet times feet is feet squared. Half of 64 feet squared is 32 feet squared. And that's good for that one. All right. So we're in our last problem. An isosceles right triangle has an area of 98 centimeters squared. Find the length of each leg. So I drew an isosceles right triangle. It's a right triangle, but it has two sides that are the same length. You might see some that look like this. You might see some that are spun. They might look like that. They might look like this. It doesn't matter. I drew it the easiest way I found possible to solve it. Here they give you area. So I know that the area is equal to 98 centimeters squared. What I don't know is how long the sides are. What I do know is that the sides are the same length because it is isosceles. So I put a variable, and I put the same variable there for both of them, x and another x. So if area is equal to 1/2 base times height, then area is also equal to 1/2 x times x. And that means that area is equal to 1/2 x squared. Well, I know what A is. I know what the area is because the problem gave that to me. So I'll take 98 and I'll substitute it in for A. So that gives me 98 centimeters squared equals 1/2. Here, let me do this because it's a little confusing now that I'm looking at this a second time. It's 98 equals 1/2 x squared. And now to solve that, you're going to multiply both sides by 2. There we go. You're going to multiply both sides by 2. I'm just trying to clean this up. I'm sorry. Multiply both sides by 2, and you'll get 196 centimeters squared, and 1/2 times 2 is just the number 1. So that cleans that up. So you just have x squared on the right-hand side. Then you have to go one more step, and you have to find the square root of both sides to get just the length of one leg, x. Well, the square root of x squared is x. That's good. The square root of centimeters squared is centimeters. That's good. The square root of 196 is 14. That's good. So the length of each leg is going to be 14 centimeters. And you can check that by doing 14 times 14 divided by 2, right? It's 1/2 base times height. So 1/2 of 14 times 14 is 98 centimeters squared. All right. That's it for the lesson. It was pretty quick. You're going to want to do all your homework problems and then go on to IXL. So do homework for practice. You've already done this problem, but now you can use your area formulas of your parallelograms now that you know how to do them, and you won't have to break them up into triangles and rectangles. Okay, so those exercises, and then make sure you do all of your IXL, as that is what is graded. All right, good luck.